Hello, welcome back. We are learning recursion. Now in this tutorial, I'm going to develop a recursive function in order to implement Tower of Hanoi game. The function is supposed to print the necessary steps. If followed, then the Tower of Hanoi problem could be solved for n number of disks. Possibly we all know the game. We have played this in our childhood, and if not, then you can just go and Google about this Tower of Hanoi game. The history is also interesting. And the myth associated is also interesting, very much interesting. And just you can go and Google and get all the information regarding this Tower of Hanoi game. So here is the game. We have these three pegs, position 0, position 1 and position 2, and in one peg there are n number of disks. Here it is 3 in position 0. We need to transfer all these disks to a destination tower. Destination could be position 1 or position 2. That doesn't matter, the problem remains same. So if the destination is position 2, then we can use the position 1 as auxiliary tower, and we need to transfer all these 3 disks to position 2 using that auxiliary tower position 1. But there are two conditions. Number 1, we cannot pick more than one disk at a time from any peg. And number 2, in the process of transfer, we cannot put a larger disk on a smaller disk. That's prohibited. So how could we do that? Actually, if there are 3 disks, then it's easier to guess where the first disk, that means the disk at the top, the green one, is going to be placed at the very first move. We can just go and back calculate to get position for the first disk, and we can just go and play to solve. But if the number of disks is higher, that means say n equals to 15 or 10 or 12 or even more, then it's really tough to guess where the first disk is going to be placed in the first move and where the second one is going to be in the second move. So they are really going to be tough. So in such situation, what we do, we actually go in the reverse order. We think it in a structured way, and the solution could be achieved by thinking in the reverse order. Here, if we need to transfer all these 3 disks, you can see that this from position 0 to position 2, then this after transfer, this blue disk will be placed at the bottom of this position 2. That means this will be transferred here at the bottom. Then on that the red will come, then on that the green will come. So one thing is clear, that the blue disk has to be at the bottom. If we just need to transfer properly for any n, then the bottom disk has to be placed at the bottom, and the disk just on the top of the bottom will be placed exactly on the top of the bottom in the destination. So for that, what we need to do, we need to transfer all these n-1 disk from this source tower to the auxiliary tower. If we can do that, then this disk becomes free, because we cannot pick this blue disk at the very beginning because there are these 2 disks on it. So we need to transfer this n-1 disk to this auxiliary tower, that means position 1. The red and the green will appear here. So this is red and this is green. I'm just writing this. And in that case, this blue is going to become free, and we can pick that and place that to the destination. That means in that case, when these 2 are removed, then we can pick this blue and can place it here, because that's 1 disk left. Now we have this green and red left here. Now we need to get back this green and red here in this position 2. Now that we cannot do in a single go. Again, the problem has been reduced, as you can see that. Now the problem is that this is the source tower, this is the destination tower, and this will be the auxiliary tower because that is empty at that point. So we need to remove this disk, that's n-1 equals to 1, to this auxiliary, and we will become free. The red will become free, and we can just move that to the destination, that means position 2. And in the next move we can just bring back the green on the top. So actually the problem is reduced at each point. So in order to just pick this blue disk, we need to remove these 2. In that case, the problem is reduced to n equals to 2, and in that case the source tower is this one, the destination is this one, the auxiliary is this one. So we need to move these 2 disks from here to here So the Tower of Hanoi problem gets reduced. So in each time we will be having a reduced problem with lesser number of disks and varying pegs. The recursion can be used. And the trivial case is that when there is only one disk left, we can just pick it and place it to the destination. So let's see how we can do it programmatically by writing the recursive function. But before that, I would like to play this game and to show you it's really amazing. So for the first time, I'm just placing it on the third, and then the red comes here, then the green comes here. So you see that we have removed all the two disks on position 1, that was the auxiliary. Now we can just move this to the destination. That's free. We can just pick it and place it to the destination. Now we are left with these two disks in position 1. So we need to get them to the destination. So for that, now the problem is there are two disks and the source is this one, destination is this one, and this is the auxiliary. So just pick this disk, put it to the auxiliary, move this to the destination, and then move this to destination. So we are done. Now I'm going to write the function in the next tutorial. Thank you.